All right, let's move on to friction at an incline. So if you watched the video last night, it was pretty, yeah, go ahead. Somebody can turn off the light. It was pretty straightforward. One more, there we go. All right, I left you with really two equations. One of them you should already know. You know that F of G is mass times gravity, and I referenced that in the video, but we really concentrated on this. Force of friction is mu times F of N. And the friction depends on normal force. It doesn't depend on gravity. Most people think it does, but it doesn't. So let me give you an idea. I did some samples this morning, and what I did was I had a block, and there were some masses on top, and I attached a string to the block, and then I pulled it to the right. And I have what's called a spring, a force sensor, a spring sensor. I can get force off of it. And when I pulled it horizontally, it read about 5.8 newtons. And I pulled it at constant velocity. Since it's at constant velocity, I know the 5.8 of the pull had to equal force of friction. So I know friction was also 5.8 because it's at constant velocity. Then what I did is I took that same block with the weights on top and I pulled it up at an angle at a constant velocity. But this time it was like 6.2 newtons. And the reason why it was more is because when you pull up at an angle, that force does two things. It slides the block forward, but it also lifts the block a little bit. If you lift the block a little bit, you affect the normal force, because the normal force is that upward push from a supporting surface. And so you can affect friction depending on how you pull the block. And let me go ahead and show you what I mean here. So I have this block. I'm going to do a free body diagram here. And I'm going to pull up at some force. If I do a free body diagram, I also have force of gravity down. It's on some supporting surface. Let me write that there. I have normal force up, and I have force of friction that opposes that forward pull. And if you look closer to what's really going on, that forward pull is broken up into a force on the x-axis and a force on the y-axis. Now the beauty of this free body diagram when you bring out all the details is you can see a couple of things. This force here plus that force there has to equal the force of gravity down. And the reason you know they have to equal is because my block isn't floating up into the air and it's not sinking into the table. So you know your arrows up have to equal your arrow down. Then what's left is this pull to the right, and then you have friction to the left. These two arrows are the ones that affect the motion, the acceleration to the right. Now when I ask the question, if I pull this block with 36 newtons, how fast will the block accelerate? Most students will concentrate on friction out to the back and the force of the pull to the right. But what you have to remember is this upward arrow and this upward arrow affect friction, so we can't ignore them. So all of these arrows, even though they look like they don't matter to moving the block forward, they really do. And I'm going to remind you guys that force on the x is F cosine theta, and there would be my angle. And force of the y would be F sine theta. So those are how you get the force on the x and the force on the y. Alright, I'm going to hand out some sample questions, and we might have to turn on one of the lights so you can read them. But here is sample question, and we'll go baby steps. The first sample question doesn't have you calculate friction, it gives it to you. So I want to see how you work in with friction. Then we will calculate friction. So there's 2 on the front and 1 on the back. And I'll continue to write in marker, that way you'll be able to see them. Okay, so the first one says, and I'll zoom in here a little bit. Hopefully we can see it on the screen. It says, to give a 19-kilogram child a ride, a teenager pulls on a 3.7-kilogram sled with ropes. She pulls with a force of 55 newtons at an angle of 35 degrees relative to the forward direction, which is the direction of motion. In addition, the snow exerts an opposing force on the sled that points opposite to the direction of motion and has a magnitude of 40 newtons. The ultimate question is, find the acceleration of the sled and the child. Anytime you have a force question, the first thing you should always do is a free body diagram. So I'm going to start with a free body diagram. Start with green. Okay, so here's my kid and my sled. And just to give you some perspective, I'll go ahead and put some snow on there for you. So the forces, F of G, F of N, F, that's your pull, and out the back is the force of friction. Alright? So that's what the diagram looks like. The ultimate question is, what is the acceleration of the cart? Well, the basic equation is F equals ma. You guys did a lot of work on this with your homework. Good job, by the way. Grades were really nice. So A is equal to the sum of the forces over m. Well, I'm going to go ahead and put some details on this. I'm going to put my force on the x, and I'm also going to put my force on the y. Doesn't mean that's a y. Doesn't mean I'm going to need them, but I'm going to put them on there just in case. My sled is accelerating that way, so the forces I'm concerned with are the ones on the x-axis. So really it's the force on the x and the force of friction. This force here and that force there and F of G down, they all cancel each other out. They all end up being 0. So I'm not worried about those. So I want to know this force here and this force here. If I list my givens, I'm going to go ahead and do that. I'm going to say mass is 22.7. That would be the mass of the child and the mass of the sled. They're together. I know the force of friction is 40 newtons. He went ahead and gave me that. The force of my pull is 55 newtons. And I know it's pulled at an angle of 35 degrees. So these are all the things I know. So I'm going to bring this equation down here. The sum of the forces equals ma. If you look at the diagram, the only forces I'm concerned with are this one and that one. Because like I said, all the rest equal out to be 0. Can I get the force on the x? Sure. Force on the x is F cosine theta. And I'm going to do this step by step and write out all the details. So I'm going to say force on the x minus force of friction equals NA. So I teased out a bit more detail in that equation. Force on the x is F cosine theta minus the force of friction equals NA. Everybody good? So the force on the x is 55 cosine of 35 minus, and they give you the force of friction, they give it to you right there, which is 40, is equal to ma. And when you do 55 cosine of 35, you get 45.05 minus 40 equals ma. 5.05 equals mass times acceleration. So 5.05 divided by the mass equals the acceleration. I'm doing this in great detail, so you wouldn't have to do this on your homework. I just want to make sure no one is confused on how I got the numbers. So 5.05 divided by the mass, which they give you right there, 22.7, equals A. And when you divide those two things out, you get A is equal to 0.223 meters per second squared. So that's an easy version because they give you F. You don't have to calculate it. They give you F. You don't have to use the mu times the normal force. So does it seem kind of straightforward to everybody? All right, so let's go to the second one. The second one is where now you have to do a little bit more work because we have to calculate. You have to calculate force. The second one says a 925 Newton crate is being pulled across a level 4 where the force is 325 newtons at an angle of 25 degrees above the horizontal. The coefficient of kinetic friction is 0.25. Find the acceleration of the crate. Again, always start with a diagram. I'm going to use green on this. I have my crate. I have a pull upwards. I know my angle, which is 25 degrees. And if I do the rest of my forces, I have force of gravity down. I have normal force up. Force of friction out the back. And now I'm going to take this force of my pull and break it into what we call components. Force on the x and force on the y. Again, x is cosine theta and y is sine theta. So why don't what would really help is if we went ahead and got numbers for all of the forces. Then we'll work our way through step by step how you solve it. Alright, let's get the force on the x, which is F cosine theta. Alright, when you plug in the numbers, I'm going to do this problem kind of quickly, and then on the last one I'm going to do it the exact way I need to see it on the test. So it's basically the test. I'm going to do the test question. The wording will be different, but if you do the exact same thing I show you on the last problem on your test, you'll pick up maximum points. Okay? So I'm going to do this one kind of quickly. So F cosine theta, let me list my givens here. My F is 325 newtons, right? There's a 5, I'm sorry. 25 newtons. I know my F of G, which is also the weight, don't forget that, it's also the weight, is 925 newtons. I know that mu is 0.25 and theta is 25 degrees. Those are all our givens. So force on the x is F cosine theta, 325 cosine of 25, and that gives me 294.55 newtons. We have that number. Let's get the force on the y. Force on the y is F sine theta, 325 sine of 25, and that is 137.35 newtons. Alright, so we have this number we have this number. We know this number, they give it to us. F of G, 925 meters. And now we have to get the normal force. Okay, well now we have to get the normal force. Well, if you look at the normal force, this is really not that bad. It's just a question of everything being equal. I know that my arrows up have to equal my arrows down, which means this arrow plus this arrow has to equal that arrow, right? Everything has to be equal. So for my normal force, F of N plus force on the Y equals F of G. So that's true. And if I rearrange it, I can say F of N is equal F of G minus force on the Y. Well, we know the force on the Y. We know F of G. So 925 minus 137.35. And you get 787.65 newtons. The reason why you need the normal force is because you need friction. And the reason why you need friction is because friction will subtract from that. And these are really the two we're after. We need this one, we need this one. But in order to get friction, you have to figure out what that is. And to figure out what normal force is, you have to think about that arrow and that arrow. So it's a big puzzle. But if you go piece by piece, it's not so bad. Alright, so friction is mu times the normal force. Force of friction is mu times the normal force. Mu they give us is 0.25. The normal force we found right here is 787.65. And let me plug that into my calculator real quickly. 0.25 times 77.65. I get 196.91. That's friction. I'm hoping everybody can follow along. I'm hoping this kind of makes sense. Well, now we're ready. Sum of the forces equals MA. Remember, the box is going this direction. So I need that force and that force. So force on the X minus force of friction equals MA. Force on the X, if you look above, you'll see it's 294.55. 294.55. Force of friction, which we got, is 196.91. And that's equal to mass times acceleration. And we're going to subtract those out. 294.5. I get 97.64 is equal to MA. Now from this point, it seems like it would be simple, except we have one more number we have to chase down. We have to chase down what the mass is. How do you get the mass? You guys can talk, it's okay. If you're not sure, I'll tell you. From the video yesterday, and I know my poor paper is just all crowded. I wish I had a bigger sheet of paper. From the video yesterday, force of gravity is equal to mass times gravity. Well, we know F of G, it's 925. So if you divide that by gravity, you get the mass. So 925 divided by gravity, 9.81. I get 94.29. So A is equal to 97.64 divided by 94.29. And you guys can plug the rest in the calculator and get the answer. It's like 1.3 something. So that's a lot. That's one problem. You guys got several of these on your homework. I want to make sure you don't skip a step. Let's turn it over to the last one, and you got a full sheet on that because I'm going to show you step by step. I'm even going to read the questions to you. All right? So this is going to be on the calendar. Make sure before the test you at least watch the video so you can get all the points. Alright, let me get that. You would, if you read it, you think it looks like the same question, but it actually isn't. Because the previous question you pulled up, and this one you are pushing down. So that's quite different. You're pushing down. So let's start with a diagram. So here's my diagram, and I'm moving to a pen. I'm hoping I can fit more on the paper. I'm pushing down. 325 newtons, and this is 25 degrees. And I still have force of gravity, and there's still normal force, and there's still force of friction. Okay? So the question, let me find the question. I'll break it down to you. Now this is not the question, but I'm really wanting you to do the steps. That's why I'm doing this for you. So the question says, what is force on the x? It says x colon. You get force on the x by F cosine theta. I'm going to plug in 325 cosine of 25. And you get the same number. 294.55 newtons. That's 3 points. One for the equation, one for substitution, one for the right answer. That's good. The second question is, what is the force on the y? Force on the y is F sine theta, which is 325 sine of 25, and you get 137.35. That's another 3 points. The next question is, what is the force of gravity? Now this can be tricky. This question gives you the force of gravity. It tells you. Force of gravity is how much the crate weighs. And it tells you in the question. It's 925. But what's hidden in the force of gravity is the mass. You know eventually you're going to use it, because the equation is mass times acceleration, right? So you're going to need the mass. To get the mass, you divide by gravity. M is equal to force of gravity over G. 925 divided by 9.81. 94.29, and that's a kilogram. So what I'm doing is just getting all the pieces to my puzzle, because I know eventually I'm going to need them. After force of gravity is normal force, F of N. Well, according to my diagram, my arrows up have to equal my arrows down. I have this arrow here, which is X, and I have that arrow there, which is Y. I'm hoping you can see the difference between this question and the last question. So now, F of N is F of G plus force on the Y gives you normal force. Because arrows down have to equal arrows up. So I'll write that. F of G plus force on the Y equals F of N. We substitute in. 925 plus force on the Y, we found right there. 137.35. Let me put that in it. 1,062.35 newtons. Then we get force of friction. What is the force of friction? It actually says force of friction. Force of friction is mu times normal force. 0.25 times the answer we got there. 1,062.35. And that's equal to 265.59 newtons. We're almost done, believe it or not. Then it asks for the sum of the forces. Well, that is that minus this. That is the force of X minus friction. We could use these, but all of these add up to be 0. That one and that one and that one, and we add them up, it's 0. So they don't count. The only two that are left is force on the X and friction. And we have those. Force on the X is 294.55. So force on the X minus force of friction, 294.55 minus 265.59, 4.55 minus 9.59, I get 28.96. And then what is A? A is the sum of the forces over the mass, 28.96 divided by the mass, which we found way up there, 94.29. Divided by 94.29, and I get 0.307 meters per second squared. We're done. How many points is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. I have about 90 tests to grade with a question like this. Can you see why the standard format? Okay, now the beauty is, if you make a mistake up here that leaves everything else below wrong, you only miss the point up here, provided you show correct work down here. See the difference? So I'm only going to mark you for the one mistake you made, not the rest because of that one. And how will I know that you're doing it right? Is if I see the equations. If I see the equation and you're substituting numbers in that are wrong, but the equation kind of makes sense, then I know what you're doing is you're carrying down a wrong answer. And I'm not going to mark you off for that. I hope this helps. I'll post it to the calendar. And good luck, I guess.